Alright, so today we're solving equations using logs. So let's have just 3 examples to illustrate. So the first one. Alright, so the first one, question says if log base 2 of 6 is equal to k log base 2 of 3 plus 1, find what k is. So log to the base 2 of 6, so we're going to use some of the log laws. And the first one I'm going to use is the one where we take the number out the front and put it up there as a power. So log to the base 2 of 3 to the power of k plus 1. Now, what we need to try and do here is adjust the right-hand side so that we can write it as log to the base 2 of some whole expression. Now, remember that one of the log laws was log to the base a of a is equal to 1. So in this case, because we're looking at a base of 2, we can rewrite this 1 as log to the base 2 of 3 to the power of k, log to the base 2 of 2. So when we have logs and we've got them added, same base, the log law says that we do what with these two things?
Adam?
No, not add. Multiply, that's correct. So it's 3 to the k times 2. Now, what we have on the right-hand side is log to the base 2 of 6 equals log to the base 2 of 3 to the power of k times 2. So the log part's the same on both sides. So both sides have got to be equal to each other, so what that means is that then the 6 and that other expression, 3 to the k times 2, they must be the same as well.
K equals 1.
K would be equal to 1. So 3 equals 3 to the k, so k is equal to 1. Alright. So the strategy there was, because this is written as log to the base 2, then we would need to try and get the other side written as a single expression log to the base 2, so that we can say, alright, these expressions have got to be the same. Alright. Alright, so that's the first type of question that you would get. You've got all of that, yeah. Alright, second type of question that you would get is something like this. Okay, so when we've done these exponential equations before, we've tried to write something, because we've got a base here of 2, we try and write the number here as 2 to the power of something. Now, in this case, it's a bit more difficult to do that, so what we need to do is we can use logs, and we can take log, because we're allowed to do anything as long as we do it to both sides. The same thing, what we can do is use logs. Now the question is, if I'm going to take log both sides, what base am I going to use? And the hint to that is looking here. Now this is a number is 2, so if I take then log to the base 2 both sides, so if that was a 5, I'd take log to the base 5. It was log to the base 2 of 11. So then the index law allows me to take this x and put it where? Not the index law, log law. Take the x and put it at the front, yeah. And log to the base 2 of 2 is 1. So with the number here and the base, they're the same, that's 1. So x is log to the base 2 of 11, which you would leave as that unless they asked you to give to a certain number of decimal places.
How did you just... If you got rid of the 2, where did that go? The 2
Which
on the
2?
log, on the left side.
Up the base.
This one here,
No, it goes X log. You're talking to
No, I'm
the
saying
second-
x, like the,
Yeah.
see how it says x equals log to the base 2, 11?
yep,
How...
this
where-
bit here,
Yeah,
where's that gone?
yeah.
Well, that bit there is equal to 1. If your base and your number here are the same, it's equal to 1.
Oh,
So this 2 here is not, it's like it hasn't disappeared altogether, it's now wrapped up in this bit.
so if it was log to the base 5 and 5, it would still equal 1?
Yeah.
Okay.
So that's why I chose base 2 here, because that number there was a 2.
Yeah.
So you'd look and see whatever that number is there and make it that base. Unless, of course, you had some weird number that was a decimal, for example, and then you would do something else, which is what this next example's about.
Yeah.
But you've got a whole number, yeah, you take the same base on there as what that number there is. So then when you bring that down the front, what you've got left with is just equal to 1, so that's x times 1.
Yeah, right.
And it's here in this log, 'cause log is the opposite to the power of.
Oh,
So 2 to the power of x, log 2 is the opposite to 2 to the power of.
yeah.
All right. Now, you can get inequalities, and you've got to be a bit careful with the inequalities. So I'll point that out. Alright, this one we're going to use the your calculator for part of it. Alright, so we've got 0.7 to the x greater than or equal to 0.3. Right, Alright, so in this case, our base number there with the x to the power of is 0.7. So it's not a whole number. So again, we're going to use the same technique we did before, taking log of both sides. And so we can choose whatever base we like, essentially. Whoops. So for convenience, just choose log to the base 10, because in the end we're going to use our calculator because it asks us the 3 decimal places. So log base 10 of 0.7 to the x is greater than or equal to log to the base 10 of 0.3. Why do we do that? Because we've got that log law that says you can take that index and put it out the front. So the next line down then we've got log to the base 10 of 0.7 greater than or equal to log to the base 10 of 0.3. Alright. So normally then what we're going to do is, if this is a times, to get the x by itself we will divide. And so it will be log to the base 10 of 0.3 over log to the base 10 of 0.7. Now, this is something you've got to keep in mind. Log to the base 10 of 0.7, so 3 decimal places, is negative 0.154. So in this case here, when I've divided by log to the base 10 of 0.7, I've divided by a negative number. And when we divide by negative numbers, what are we going to do with our
Flips.
Got to flip it around. Alright. And so log to the base a of any number that's less than 1 is negative. Alright, so it's something to keep in mind when you are doing inequalities. If this number you're taking the log of is less than 1, that number will be a negative number, so you need to flip your inequality. Alright, so then we get our calculator out. And I've used log base 10 because that's just programmed into the calculator. So that makes life nice and easy. So when we do that, log base 10 of 0.3 divided by log base 10 of 0.7, 3 decimal places, which is 3.3755. So 3 decimal places, correctly rounding is
6.
6. Alright. Anything else? Any other questions? Clarifying? No? Alright, so the other thing you've got to keep in mind with the inequalities is when you get to this and you divide, if this number here is less than 1, so between 0 and 1, because of course we can't take logs of negative numbers. So if this number here is between 0 and 1, in fact when you do the divide, you're dividing by a negative number, you've got to flip that. Alright, so that's 5G.